let's try this vertex graphing. So where is the vertex for number 13? So we got to be careful. The one thing that could get you is that the sign is always the opposite for the x. When it's in parentheses in general, the sign is opposite. So the vertex is at -2, comma -3. Just the x is different. So I know -2 on the x, -3 on the y. Right there. There's the vertex. The axis of symmetry. I call it A from the x. Remember, that's just that number. And does this open up or down? Okay. And how can you tell? Opening up, opening down.
Oh.
Yeah, so recall, okay? Recall. Positive, opening up. Opening up is positive. Up, positive. You know it's going to be opening up to start off with. That's good to know. And now I'm going to plug in 0. And I'm going to do this mentally. You can write it out if you like. But I'm just going to imagine plug in 0. What do you get? So I'm finding right here. I'm finding the y-intercept by plugging in 0. Did the same thing over here to get -9. Plug in 0, 0 plus 0 is -9, and I got the y-intercept. I'll do the same thing I did in standard form. Plug in 0, 0 plus 2 is 2, 2 squared is 4 minus 3 is 1. And then go ahead and mark the other side as well. Let's mark the other side. So you get, is that it? Is that it? Exactly 2 away, right? It's 2 from the axis on that side, 2 from this side, and then just with those 3 points, you're going to make the best parabola possible. Looking at mine. Remember, never go straight up. Keeps on going out and out. It still has a slight curve through it. So to take out all the explanations and the talking, which one would you say is faster? This one or vertex form?
Vertex.
Vertex form, standard form. We have to do all this -b over 2a to get the vertex, right? We had just to get 2. Then we had to plug 2 back in to figure out its -1. Then I had to do that. So this method, when it's in this format, a little bit faster. By the way, you'll note the a value here, since there's no number in front of the parentheses, the a is 1. Positive 1. Let's go down to 17. So what's the a value here on 17? -1. So does it open up or down?
Down?
Down. So negative. I know it's going to be doing this just because of that negative over there. That's the a. It's -1. The parabola opens down. What's the vertex? -3, comma 3. So x is the opposite sign. Yeah, is that your h value? H and k. H is the opposite sign. K is positive. So here we go. -3, comma 3. Right there. What's the y-intercept? Plug in 0. What do you get? plus 3 is 3. 3 squared is 9. Negative in front, so now it's negative 9. Negative 9 plus 3 is negative 6. And since it's 3 away from the axis of symmetry, 3 on the and you're done. Okay. So hopefully you appreciate this. It's a little bit easier to graph with, right? Compared to where we were doing last. So the question is, if this is so nice to graph with, this is also going to be so nice to solve with, and this if it's so nice to graph with, how can we change standard form, what we're used to, into this format? And skip the whole negative b over 2a and plugging it back in, just have this format. How can we do that? That's what you're doing up front. Right. And it wraps and ties in that whole idea of completing the square. The vertex form, how do you get that squared part? It's from completing the square. So let's go ahead and complete the square. First of all, is this the right number in order to complete the square? What number should be here? I mean, negative 16. What's the correct number that should be here? What is it? 64? 60? So we have 67. So what I'm going to do is rewrite this. Put 64 there. However, these do need to be equal to each other, right? So what can I add to this in order to have it equal to the one above? Add 3 more. So now I have the same thing. I have x squared, negative 16x, I have 67, and then I have 64 plus 3, which is also 67. So I just need to keep it equal. But now I got the right number, the number I want there. So we have to choose this number there. So now we can write it as what? X minus, and we just bring down the plus. There we go. Ready to graph. Just a little small step. Where's the vertex?
So we can take out 3 every time.
No, it's whatever to make it equal to the one above. What's 67? I have to do plus 3 to make it 64 plus 3 equals 67. Complete the square. Half of negative 16. 8. Third. Just like we were doing on the one. Same exact thing. So what we're doing before completing the squares, it seems like, okay, it can do this. That's nice. I complete the square. So what? Well, this is the so what. You can actually use it to graph, and it's a lot easier to graph this way. Sometimes we'll still use that negative b over 2a. That's still going to be useful, but you're going to find in most cases this is a nicer approach. All right, so let's try 3. What number would you like to have here? What would be a good number? 100, right? Half of negative 20, negative 10, negative 10 squared is 100. So we can rewrite this as x squared minus 20x plus 100, and then what? Plus 9. Yeah, to make it equal to the 109. Because these have to be equal, they have to be the same. All right. And the first 3 we factor. That equals 6 minus 10, and then on both of these, the a value, there is no a value, just like the 1 in front. You write it just like when we have x, when we have x squared, we don't write 1x squared, we write just x squared. So the number's missing in its multiplication, it's always 1. If the number's missing in its addition, it's subtraction, it's always 0. So if we did this process and there was no number out here, it's automatically a 0. So, all right, write down the vertex. And does it open up or open down? All these good questions there. It's good to keep in mind that while we're looking only at equations, we can graph every single one of these. Do one more and I'll let you guys practice a little bit. And let's go to actually 1. So what number would you like to have there? What would be perfect? So number 4? When I say perfect, that means perfect square. What is it? 36. All right, keep it equal at the top. What do I need to do? What's that? Add 9? Minus 9, right? Equals 27. 36 minus 9 is 27. So you might have to add like the first two, but you got to do whatever it takes to keep it equal. So subtract. So this equals x minus 6, and then minus 9. So the vertex is at comma 8. Positive 6. So the signs those off. I'll leave 2 for you. That's 4. That's subtract. Yeah, so why don't you practice on 2, 5, 2, and 2 and 6. Maybe 2 and 6. There it goes. Check with someone around you. See if you've got the hang of it. If you think you really got it, try it 100% by yourself and then check. If you get stuck though, then check as you go. Help each other out. Because of new people, right there. New people that know. 536. Make this equal to whatever this is. 109, and then 100, 9. Equals 7, and then 4. Whatever it takes to make those equal. Clean the square. Half a negative 5. Square root is 36. Same as the warm one. So let's go down to what if there's a number in front? Again, right back to the warm-up. What would be the first step we'd probably do here to factor?
Take out
the
2.
Yeah, the 2, or in this case, negative. Yeah, they got negative. So everything we've been warming up on is actually leading up to solving and graphing these problems. You need all those different skills, GCS, and everything. And realizing that you miss one little negative, it throws the whole graph off and everything is incorrect because the negative you get the exponent. So if distributing is the opposite of factoring, and distributing is multiplication, factoring is like addition. That's the opposite, right? So we have to divide each of these by this factor, negative 2. So negative 2x squared divided by negative 2 is x squared. Right? negative 32x divided by negative 2, positive. And then negative 118 divided by negative 2, positive.
54. Oh, never mind.
Half of 100 is 50, half of 18 is 9, 50 plus 9. And then we can go ahead and complete this square. We'll just have this negative 2 up front. Okay. So what number would we like to have?
Oh,
What is it? Half of 16? 4, 8. 8 squared
Oh, never
is
mind.
64. So we need to add 64. But to get it equal to 59, minus. So same idea as we just did above. We'll just have this negative 2 floating. Alright, keep going. These all factor to x plus 8 squared. Bring down to minus 5. Now, here's one more step though, we're not done. We took out that negative 2 in the beginning. We actually have to put it back in. So distributed, we have negative 2 x plus 8 squared. And we have negative 2 times negative 5. And the same negative 2 we took out in the front at the beginning, we got to put it back in. It really only changes this k term over here. So my vertex is what? Close. Negative 8. Yeah. And it's a coordinate, so parentheses. Alright, so I'm going to have you guys get at least finish all those. These last ones might be a little more tricky because of this one last step right here. So this is the only thing different compared to 1 through 8. Or, yeah, 1 through 6. 1 through 6 are exactly the same, and then 7 through the rest of the class, 7 through 12, you'll have this extra step of the GCF you took out from the first step, you have to put back in on the last step. So you have to do the whole thing. Okay. And then you guys will be ready to graph them all. You guys might also recognize that this looks something like we could solve. So in 2 days, all we're going to do is say that equals 0. You can subtract 10 on both sides, divide those both sides by negative 2, and then take the square root of both sides, and then you have the x-intercept. So this is all leading up to also solving. But we're just going to stick with this first part. So, yeah, my point is we're going to keep going with this for a while. It's not going away. It's going to be very important, so make sure you do your homework on it so you become very good at it.